All right, that's what happens when students come by during office hours when I'm recording a lecture. So we were talking about forecasting red and green balls. So we took, what we want to do is, instead of just using the latest ball as a prediction, we're going to use the most recent 5 as a prediction. Now, why wouldn't I use the whole thing? Why wouldn't I just take all of the draws? Well, that's not necessarily a good idea in a time series because the underlying process may be changing. So in the case of a stock price, we generally think that stock prices will trend up. And so if I used the whole history of stock prices and did an average of that, I would way overshoot in the Depression era and very much undershoot in the modern era because I would be doing just an average across that whole thing. So rather than do that, we would just use the most recent information, but not only the most recent data points. So we're incorporating some data from the recent past in order to wash out the noise. So even though we end up with maybe a little bit of stale data, we can get rid of some noise. So there's always a trade-off with using information from too far in the past with including too much noise in your model. So let's say that we've decided that the correct trade-off is to look at the most recent 5 draws from the jar and do a moving average of that. So my forecast for the next ball out of the jar would be quite literally the average of the previous 5. So if I label red as 1 and green as 0, I have 0, 0, green, 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 red, green. So in terms of an average, that's 0, 0, 0, 1, 0. I multiply my data times the number of observations, or the weights. These are just all equal weighted, but you can do weighting if you like, a weighted average. And then divide by the total number of all the weights. So these were all equally weighted, so it's just really the average of the last 5. Add up the top, divide by 5. We have 1 red, so we would get 1/5 red. So our forecast for our selection next period, if I was to stick my hand in and draw a ball now, I would predict a score of 1/5. Now, obviously, you can only get 0s and 1s, but that would be the most accurate. That would be an accurate forecast, or more accurate than just picking 0 or 1. So if I take stock prices over this whole big history, back to the 20s, I can do a 24, this is a 24 period moving average. And let's see, I think our data was by months, and so this would be using the stock price over the last 2 years as our prediction. So you can see here as I look at this that we are not washing out the business cycle risks. Notice the red line has lots of up and down fluctuations, but we have a nice smooth drop, right? So we have bear market, bull market, bear market, bull market, bear market, bull market, bear market, bull market, and so on. So this horizon is managing to maintain the cycles but wash out the seasonality and the noise. So we have, as a result, a nice smooth movement through the business cycles. And so if that's your objective, if you want to be able to eliminate the seasonality and the noise and yet retain the cycles, this frequency moving average would work for stock. So in general, there should be a moving average that retains the variability you want and gets rid of the variability that you don't on average. Another forecasting model is exponential smoothing. So in moving average, we take the data, some recent history of the data, and incorporate all of those data points into a prediction. So exponential smoothing works a little differently. So exponential smoothing, rather than using past data to predict future data, it uses the past forecast and the current data to predict future data. So do we use any past data explicitly in exponential smoothing? No. So the only data we use is the current data point. That's it. Notice though that the forecast from the prediction for today that we made yesterday is going to include a lot of old data in it. You can think about it as the forecast gets continually updated with new information, and so there's a lot of information in the old forecast, and we're just adding to that information by including the current observation. So if I have if I had my forecast, and let's say I had a green ball and then a green ball and then a green ball, and my prediction, let's imagine I was forecasting green, so I wouldn't update it all. But then once I have a red ball, so that first one, when I have a red ball, that would be a 1. So my old forecast was 0. I was predicting green balls the whole time. And now suddenly I have a 1. Well, one way to do that would be to set alpha to 1. And then we would say, well, old forecast was 0. This is 1. 1 times 1 is 1. 1 plus 0 is 1. So if we set alpha to 1, what does that mean? We're throwing away all of the old data, and we're just using the new information exclusively to forecast. So that would say that our forecast for tomorrow is equal to the data today. That's if you set alpha to 1. But what if we set alpha to 1/2? Well, now my forecast here would be 0, 1 minus 0, where you had a red this time, 1. But now alpha at 0.5 means this is going to be 0.5. So I have 0 plus 0.5, the result would be 0.5. What does that mean? That means that we've equally weighted the current observation and all of the previous that got rolled into this forecast. So alpha is the fraction of your new forecast that comes from the current data. If I set alpha at 50%, half my new forecast is the current observation. If I set alpha at 1%, only 1% of my new forecast is the current data. So the bigger the alpha we predict, the more noise we include in our model. So if we select a low alpha, we have really smooth predictions. If we select a high alpha, we have really variable predictions. And again, the more smooth, the more information we're washing out, but the more smooth results you get. Now, this exponential smoothing model can be this formula here that defines it can be explicitly typed into Excel pretty much straight as is. And but the trick with these forecasting models is keeping your time straight, knowing which rows to do where. So anyway, here's an example. So if I look over the recent Dow Jones history in terms of this data, you have lower returns, only 12% over 5 years. Why? Because recent returns have been poor. So if we were to use an exponential smoothing model, we might predict a lower return because we're putting more weight on more recent data if we use a higher alpha. So just like last time, instead of using an average of the regression errors, we can do an exponential smoothing of the regression error and get a higher value. So just to show you what that looks like, to show you, okay, this is what it looks like in numbers, and then we'll do a picture in a second. So here's our red-green thing, and if I start with a prediction of 0.5, this is going to be imagine this first observation. Before I draw that, I predict 0.5. So now I have new information. I drew a ball. It was red. So 1 minus 0.5 is 0.5 times 4, 0.2. My new forecast is 0.7, right? I drew a red ball, so now I think red balls are more likely. Second observation, green ball. Update, new forecast 0.42. So now I have a belief that green balls are slightly more likely than red balls. Red ball, Now I have a prediction that red balls are more likely. Now notice though that we didn't go back to 0.7. So what's happening here is all this old information is incorporated in that 0.42 number, right? The 0.5, the 1, and the 0 all made it in 0.42. And so even though we're only including the most recent observation here with the 1, we are implicitly including lots of old information because we have the old forecast. So here we go. This is alpha of 0.03. And you can see we've almost entirely smoothed out everything. We have a little bit of cycle in the depression, but otherwise we just mostly have there's maybe, we're noticing these big cycles that take, this is over a 40-year horizon that this is happening. So we've identified a longer horizon movement. Now if I go down here, I can make it even smoother, and now I'm just, I'm washing, I've effectively smoothed over the crash of 29, and I've just following through the post-war boom, and here we go. So just to compare these, I'm more smooth with a lower alpha than I am with a higher alpha. So next we will do moving average and exponential smoothing in Excel.